All right, in our first example, we have the series whose terms are 1 over the square root of n plus 1, and we'll call those terms a sub n's. So your first inclination will, maybe we could use a comparison test. With the comparison test, we kind of want to show this divergence, right? Because this is looking like n to the 1/2 power, and it kind of resembles a p-series test where the exponent's 1/2. So I'd like to show that this somehow diverges. I can't really compare it to 1 over root n. Now I know that 1 over root n, if those are the terms of a series, then that diverges. But in order to show that this series diverges, I need to have 1 over root n to be, in fact, smaller than 1 over the square root of n plus 1, but that's not the case. Just check for n equals 1. 1 over root 1 is 1. 1 over root 1 plus 1 is 1/2, and well, 1/2 is less than or equal to 1. So I can't use the comparison test previously that we just went over to show that this series diverges. Okay, so it's tempting, like, oh, we'll just compare it to 1 over root n. We're kind of close. We're going to use 1 over root n as my b sub n, but we're going to use the limit comparison test. So we really don't even care about whether a sub n is bigger than or equal to b sub n, or b sub n is bigger than or equal to a sub n. We just care that they're kind of similar in the fact that we can take a limit. So let's go ahead and we'll keep b sub n as 1 over root n. And if you will, go ahead and take the limit as n goes to infinity of a sub n, which is going to be 1 over root n plus 1, divided by b sub n, which is 1 over root n. And see if you can't come up with one of these three cases and then justify that our series diverges. If you can do that, go ahead and check your answer with what we have here in a few moments. Hit pause and do the work, and then hit play when you want to compare your results. All right, so we can still keep the b sub n's as 1 over root n, but we're going to look at the limit as a sub n over b sub n as n goes to infinity. Okay. We also know that the series whose terms are 1 over root n diverges by the p-series test, where p is 1/2, which is less than 1. So here we're going to go ahead and take the limit as n goes to infinity of a sub n over b sub n. So here's my a sub n's. There's my b sub n's. Doing a little bit of quick algebra, I get limit as n goes to infinity of root n over root n plus 1, which is going to be 1 in the limiting case. That's the case here where we go to a real number L. So since our series of b sub n's diverges by the limit comparison test, so does our series that has 1 over root n plus 1 as the terms in this series. All right, let's look at a second example. And before we move on, just wanted to state that last detail, that we do know that the series of 1 over root n diverges by the p-series, where p is 1/2. So now let's go ahead and look at example number 2.